Hello and welcome to Java Me. My name is Muhammad Al-Asmari and I'm going to present and talk about some technology called Java Me. Probably you know Java, or let me say you should, because I'm not going to explain anything related to learning Java, neither this presentation. However, in order to understand Java Me, you need to be aware of, or at least know uh, the fundamentals about Java technology as programming language. This presentation does not deeply go into stuff like MIDP3 and IoT, Internet of Things, because I see it as advanced Java Me level. That's based on this presentation, and other reasons I'll mention them later. So, what does this presentation cover then? Should I watch the video? And if I did, what I'm going to learn? Hmm. Interesting questions, and the answer is in the provided content lists. If you are watching this video for the second time or looking for a specific point, just go ahead and click the link. Otherwise, enjoy the journey. First, we will start with a little introduction and definition, followed by the important history of Java Me. Then we will zoom in to understand some terms and Java Me architecture. After that, we will see where it's implemented and the tools that's still available today. And then, for time's sake, I'll leave the rest for you to read it from the list. Thanks. Okay, what is Java Me? Is it Java Me or J2ME? Well, we know that Sun renamed all their APIs. Java Me was J2ME, as Java Standard Edition was Java 2 Standard Edition, and Java Enterprise Edition was Java 2 Enterprise Edition, Java 2 EE. So I see there is no difference, but currently called Java Me, and it stands for Java Platform Macro Edition. The main reason of creating this type of Java was handling the issue of limited capability embedded device and make some applications work. When I say limited capability device, I mean limited processing power, limited system memory, limited storage capacity, and sometimes less battery power, as well as limited connectivity to the internet. Therefore, it requires different kind of virtual machine. However, there's no free implementation of Java Me runtime environment that you can download. In other words, any Java Me hardware based should be supported by the manufacturer itself. The exception here, if it has an operating system, then things get different, because you might be able to use Java 2 standard or Java Standard Edition instead. Now we know what Java Me is. Let's see some background. The most prominent events in Java Me history are: in 1990, the division idea came. Java became Java Enterprise Edition, Standard Edition, and Macro Edition. Of course, as Java 2 EE, SE, and ME, respectively. If you are thinking about searching because the name was 2 EEC, I mean, uh, in 2002, Mobile Information Device Profile, what's called MIDP, appeared. Therefore, all the previous ones were MIDB1. In 2004, the revolution started. Millions of devices became JavaMe based as second generation devices using MIDP2. In a minute, we'll see what is MIDP. Uh, the last important events are the emergence of MIDP3 in 2009 and Java Me 8 by 2014. Before going to Java Me architecture, let me emphasize some important terms and explain them. Here, the first is CLDC and CDC. CLDC means Connected Limited Device Configuration, whereas CDC means Connected Device Configuration, no limited. So, CLDC for mobile phones that have, like for example, limited memory starting from 160 to 512 kilobytes, while CDC is for bigger devices with more memory and more robust network connectivity. Both CLDC and CDC represent a basic set of APIs and virtual machine features that any JavaMe device must support. They are virtual machine mandatory specifications. Moving to the third term, which is a MIDP, means Mobile Information Device Profile. Based on the previous configuration, it represents the collection of APIs for other library interface, storage, and so on. The next term is MIDlet, bandlets. Any MIDP application is an instance of the library javax.macroedition.midlet, and uh, medlets represent the real lifecycle application and its method. Think of it like applets. However, it must be executed in host environment called application manager. So, to summarize, are you going to develop a JavaMe application? Then you should know whether the device uses CLDC or CDC, then which API, which is usually MIDP2, and then make your medlet. In order to understand a JavaMe architecture, I think we need to see a general overview for Java body, all Java versions. Looking at the graph, the colored parts, the parts that are not black, are JavaMe architecture. Let's start from the bottom to the top. After the uh, virtual machine, the JavaMe architecture will be the configurations, then profiles, then the API. This is the stack order: configuration, profiles, APIs. The reason of this division, configuration, profiles, and API, is because of what's called JCP, Java Community Process. It's a group of experts made some principles. If you want to design a JavaMe based phone, you have to select the configuration, profiles, and optional APIs for your product first. And after that, you can start producing. That's the thing that your phone or device gonna support. And that's the old way of doing stuff. I'm not sure about how things now going on. Because the source I've taken was uh, from Sun Microsystem, and I'm not sure how Oracle handles stuff. Uh, Looking to Java Enterprise Edition, Standard Edition, and CDC, we can see that all of them use a complete Java virtual machine. Sometimes some people think that Java Enterprise Edition might use like something different than normal Java machine, the normal virtual machine like hotspot. However, it's still a Java virtual machine, but different implementation or vendor due to some reasons. The other part of Java is CLDC, which, as you see from the graph, use this KVM as its Java virtual machine. So, what is KVM? It's the smallest general purpose Java virtual machine. It's a subset of Java virtual machine, aims to saving Java memory, runs effectively on low power 16-bit or stronger or higher, with terrific performance in resource constrained devices. So we know what's KVM now, and if you interested to know more about how they did stuff or how they did change JVM to KVM, there are some resources at the end of the presentation you can check. But in this presentation, I'll focus on the CLDC more. CDC we will not discuss. So the three components, green, blue, and red, green, blue, and red boxes together will give us a medlet, a Java ME application. If you forgot their meanings, you can go back and see what they are. One thing I want to say, if a developer decide to use some of additional API, the higher level of API, probably the application might not work on any other devices that doesn't support the same extra API. That's why it might be called like custom application. Where can we see Java ME? Many devices support and use Java ME technology. We see these devices ranging from general purpose to specific, like pagers, all PDAs, Raspberry Pi, M2M modules, sensors, microcontrollers, and so on. The last devices are techno, I mean, piece of techno electronic devices. What about mobile phones? Our closest friend. Well, some mobile phones does support Java Me, do support Java Me, and some uh, do not. Historically, no one disagrees that Java Me was the most dominant platform. Currently, things have changed for the following reasons. When we think of Java Me devices, we need to remember uh, that they are or they have limited resources. So when we think uh, when a device has enough resources, it doesn't need Java Me anymore. We could use Java Standard Edition. Like for example, I mentioned Raspberry Pi uses Java Me, which is the case. However, I found some website and some people, or let me say, there has been some improvement that lets Java Standard Edition work on it, but with some issues. So the thing that controls stuff is the resources. Second, some limited resources phones are there, but maybe not around you. I mean, for example, they might not be in development countries. Let's take a deep look on the phone system to see Nokia, for example, Series 40, and some of its operating system, the one called Asha, still support Java Me. Old BlackBerry system does, but the new does not. Windows Phone, unfortunately, does not. iPhone does not. Android does support Java, but Java Standard Edition. Android phones have enough resources. Why Java Me? So the questions might come here. Since Android supports Java Standard Edition, why Java isn't famous like PC, like in PC? Well, answering this question needs a separate presentation, but I will point to the main problem, which is Android does not, have a Java virtual machine. It does implement an Android runtime specialized virtual machine called ART now. The other question is, are the aforementioned points indicate Java Me extinction? Is it like going to die? The answer is no. Oracle has made a great leap by releasing MIDP 3 technology, which was made to start the race in Internet of Things technology and make the small and large devices talk together without any problem based on the infrastructure. I won't discuss MIDP3 further in here because I am not aware of any group of phones supported yet, as well as I'm not sure about the license. However, it remains that Oracle has a strong plan for Java Me devices and developers. Good point. Therefore, let's see how we could develop a Java Me applications. The first step towards developing is to know what tools you need to start writing such applications. In order to write Java Me application, you need to download System Development Kit, or what's called SDK. It's available freely on Oracle website, and it provides you with runtime machine and emulator as well. Most of SDK versions come with the NetBeans and Eclipse plugin choices, which make it nicer too. After you install it, you can start use it immediately. Before we see the example, let's uh, take a look how the life cycle looks like, and then main components of JavaMe application. When you build a JavaMe application, you need to or you will end up with a jar file. Contains a manifest.mf file and .jat, or what's called Java application description file. All these files created automatically, but historically JAT was important, and through it you can download the real application onto the phone and get other information. Later things changed. The JAT file became not that important. Jar and included manifest file enough. The other component is the application manager. This is the part that's responsible for starting, pausing, stopping, and installing Java application. It's the JavaMe application runtime, representing the intermediate between the operating system and the application itself. When a midlet, you should know what midlet is, begins execution, the application manager first called the zero argument constructor to create a new instance of the midlet. The constructor typically does almost nothing about initialization unless you force it to. Uh, there are three states a midlet can take during or for its life cycle. Started, paused, and destroyed. The main or the application manager places the midlet or the current your JavaMe application in the paused in three cases. When in the beginning, when the constructor returns, also when the application manager calls the function pause app, and when the midlet call itself by using notify paused function. The application manager places the midlet in the start states in two cases. When the application manager calls start app method, and when midlet call itself by resume request function. Any state changing happens, it might involve releasing resources and could be done many number of times. The midlet may enter the destroyed state from either paused or active state by a call to destroy app method and releases any resources it had. Of course, it might save required information. Midlet also could destroy itself by calling notify destroyed function, which is the case when you close the application. There is some vague area in here. Why is post application state called is an example of such a question. Let's assume that mobile phone receives a multimedia message, MMS. The application manager must help the phone to free some resources to receive the message. So, application manager may pause execution midlet only to free up memory, However, if the pause operation does not free enough memory, the application manager then calls destroy app immediately, and I see it as the worst case scenario to release more. Uh, what I want to say in short is it's really difficult to predict all the transition triggered by the application manager, but the midlet can only have three states: start, pause, and destroyed. We still need to know about the user interface because mobile phones usually do not have terminals like PCs. In other words, user cannot see anything without forms and Windows user interfaces. The default package is LCDUI. On the right is a simple graph for LCDUI package, which means it's available in all Midlist applications. All you need is to import them. Starting from the top, display represent the device screen. Then screens and canvas classes are the two choices that a developer can have. Both implements displayable interface. Think of screen and subclass like Art AWT or Swing library in Java Standard Edition. Once you create your form and its element, you have to switch the display to it as the last line does. The other choices is going with canvas, which is the hardest way for a variety of reasons. You need to think about different screen sizes, different resolution of screens, different color or grayscale screens, different input capabilities, numeric, alphabetical keyboard, soft keys, and the worst is touch screens. It's like building a whole new user interface element from scratch and keeping tracks of state change with limited memory, which is really hard. So why Canvas? Think about building a game. You need a simple interface at least to manage some choices. Canvas is good here, but still, you did not build a complete library. In brief, there are two choices for Java ME user interface: high level using LCDUI package and low level using canvas and graphics drawing. Another excellent choice to avoid using LCDUI package is LUIT. LWUIT. LUIT stands for Lightweight User Interface Toolkit. LUIT designers say they got the idea from Swing, which make it more flexible and easy to use, especially for Java Standard Edition developers. Furthermore, LCDUI library does not look similar in all devices. Every device got to interpret it in its way. However, LUIT is uniform in all devices, have the same interface. Another reason that push you to use it is it only requires MIDP 2 and CLDC 1.1, which is available in all devices. Finally, LUIT provides some elements that are not available in LCDUI package. Anyway, if you decided to use it, there are lots of examples and presentation that help you with. I don't think I have time to go for it, but that's a choice for user interface. However, if you decided to build your own framework One of the excellent books is Pro Java Me apps. It helps you plan it right. Because in Java Standard Edition, we used to think about like some reusability for object-oriented programming, but with Java Me, you need to think more in terms of efficiency, even if you break some design rules. This is a trivial example aims to show you the structure and logic of Midlet. Before you start building any Java application, as I said, you need to specify the target platform, configuration, and profiles version. This example uses CLDC 1.1 and MIDP 2. Looking at box number 1, we see that we imported all classes we need related to LCDUI package, except midlets. It's vital for all midlet applications. In box number 2, we create our class and extend it from midlet. And based on that, we have to override 3 methods: startup, post app, and destroy. The 3 life cycle states that I explained before. In start app, we create a new form with a title hello world and a command exit with a listener. Then we switch the device screen to it. The output exactly looks like the blue screen, right? Only an exit command. Once the user clicks on it, the application manager will destroy the application and close it. Simple like that. If you know Java, it's nothing a bunch of library that you need to import and follow the 3 states. Your code must be inside start app function. Okay, here's how we download Java uh, system development kit and the other required tools. We just googled it, Java 8 on Raspberry Pi, for example, or any other stuff. When we click on the link, it will take us to this web page. Accept the OIT license agreement, and then download the system development kit. We will take LCDC, the limited target devices. Okay, here we have 2 electronic pieces. Either we want Raspberry Pi or we want Freescale FRDMK64F. No, we want this. Well, let's focus on this now. Just click on the link and it should take us to okay, register your account, login. Here we have the download file. Now we start downloading and install it. Also, you can click on Oracle Java Me SDK to download it, which will take you to this page. And as we said, we will click on download. You have to accept the license agreement. Yeah, which operating system? As I said in the web presentation before, the most important two for NetBeans and for plugins. We'll take NetBeans plugin and download it. Done. Here's a folder that contains uh, all the plugin NetBeans file after I extracted them from the zip directory. I'm going now to import it through NetBeans. Here's NetBeans. We will go to Tools, Plugins, and download it at Plugins. Uh, and yeah, which plugin we want to do? All the plugins, we want to install them. Open. See all of them inserted. Click install. Accept next until you finish everything. You got to restart IDE either now or later, but and complete uh, installing the files. NetBeans starts updating and including your modules. Just wait. Okay, now we restarted the NetBeans IDE. Let's try to create a new project. Okay, here's the new project. Java embedded application. If you did not get this screen, that means either your Java development kit JDK is not updated, or you don't have JSDK. Download them both and install them and try to make a new project Java application. You should see this screen. As we said, you have first to make sure a configuration, which is here CLDC, not CDC, and second thing is MEP8. ME, the first ME is Java Me, okay? The second EP is it's embedded profile, the profile, additional profile. You can check the website and see what additional APIs provided for developments, and then you just name the project and then you click finish. Okay, this is the class Java Me application 1.java. Yeah, as you can see, it's extents of medlet, and you see start app and destroy app is overridden. So what happened to post app that you've talked a lot about it? Well, let me say something, that this is Java Me 8, and it used MIDB3 that I did not cover. I didn't want this example to be outdated, so I just wanted kind of in the middle between stuff, so you know what how things were and how things now. So yeah, let's take more example and see. But uh, about post app method is it's not a it doesn't need, I mean, pro developers and application manager doesn't need it anymore. I mean, one of the things that Internet of Things concepts and MIDB3 supports is it could handle the concurrency and the things without, pushing the medlet to being pause app. So that's a good thing. You don't have to be worried, and things get more clear now. So that's one of the things that became, but still it's the same structure. Let's look to some stuff that you might need to know. Click right click on application, project file folder, and select properties. uh, you see it uses JDK. It's nothing here much important. Yeah, here's the configuration, and here is the profile. uh, Application descriptor, what is what's called JED file. Here's some information: the name, URL, which version. You can update it as much as you want. uh, I don't go to the differences here or other stuff because it needs to be explained. Okay, what else is important you need to know? Signing, if you want to be more like, I don't know, certified, more, yeah, something document like really belong to you, more security. Yeah, obfuscating, you should use this choice and install it just to make it difficult for people who want to reverse engineer your code. At least you'll make the process really painful for them, and they will remember your code. Yeah, that's all. Let's go back to the code. Okay, here's an example of Raspberry Pi Model A. As you see, it's a chip. It like what's called like single board computer or something like that. It usually used for computer science kids teaching. So let's look at the model, but with more clear graph. Yeah, as you can see, it does have almost, yeah, everything. You see, there there are LEDs, the lights, and got USB ports, CPU, GPU, or Ethernet, HDMI, other ports, everything, everything. And JavaMe can help you monitor and control these stuff. So let's see. Back to our example. Uh, as you see, it's just normal Java application, normal midlet. Let's write our simple example. Just println statement system dot out println, and then write, yeah, this is my first JavaMe app. Hooray! Now you got to run the program. We did nothing. It's just simple. It takes some time. So once you have the emulator loaded, you should leave it. Yeah, you should leave it open. It just to save your time. Okay, now we got it. The program is working. See, here's the heap size, and that's why it's called LCLDC limited configuration. You need to go. It doesn't surpass 8 megabyte. And you see here is AMS, which is the application manager that we talked about. Now that it's running, you can't stop it. So this is your application name. This is just an emulator. So uh, as you can see, all the stuffs, all the electronic parts that we talked about or we saw, you can see them in here. Everything, you can program them, you can do whatever you think. It's an interesting stuff to look at, especially encourage kids to learn more about things like this. uh, you see, yeah, look at the ports, the LEDs. uh, we didn't touch any of these. There are a lot of resources and books that help you program and learn things about Raspberry Pi chip, but we are not going into this stuff. Let's see, where is our statement? Yeah, click on output. You see, my first JavaMe app. Uh, Sorry, because I didn't clean the output, so just repeat it. But it should be only one statement. That's all we need to know, and you can stop, so it saves your work. I'm sorry, this is the output button. It was not screen, couldn't reduce it, and you will see the any println statements in here. You can stop and run again through your software. Yeah, the last thing I want to tell you is for one of the interesting articles that you should read or Google it is like JavaMe 8 Raspberry Pi plus sensors. Look how Oracle did some interesting stuff with it. Here's the Raspberry Pi, and they integrated the motion sensor through the GPI I/O port number 24, and they use also distance sensor and flame sensor. It's already pieces they connected together through the ports of Raspberry Pi, and then they start programming stuff using JavaMe. I think it's interesting enough to look at it and see how things work. And that's all what I have. Thank you for watching and goodbye.